the measurement of current and voltage with the help of galvanometer. You see, the galvanometers can't be used directly for measuring current or the voltage. One simple reason is that it has high resistance, and whenever these are connected with some circuit, they change the basic current flowing in the circuit, and that affects on the reading. Second thing is that for any current, howsoever small, even up to the order of microampere, we need some deflection on the pointer scale that we are using. So from that point of view, we have to be alert, and we need certain modifications for getting a meter and voltmeter. Let's focus on a meter first. This is used for measuring the current. Current is always equal in series combination. That's why the ammeters are always connected and preferred in series combination. But soon as the ammeter will be added in series, it will change some amount of current. Suppose initially the current was I and it reads I dash, then fractional change in the current would be equal to I dash minus I upon I. Ammeter has to be connected in series. So, in order to avoid the abrupt increase in the resistance, its resistance should be very small. Ideally, the resistance of ammeter should be 0. Now, in order to have very small resistance of ammeter, what we do, we connect a shunt with the galvanometer as shown over here, a shunt and galvanometer. Galvanometer's resistance has been shown by letter capital G, and the current that passes through the galvanometer, that is represented by the letter small ig. Sometimes this ig is also known as full scale deflection current. Suppose the current that you want to measure is I and Ig will pass through galvanometer. The current that remains for the shunt is I minus Ig. In parallel combination, you see both will have the shunt and the galvanometer will have equal voltage. By using this relation, we find Ig upon I, this is equal to S upon S plus G. And this could finally be converted into the relation that has been shown over here. Simply by just inverting the whole thing, you get I upon Ig, and here this side you will be getting 1 plus G upon S. So if you take to this thing right side, you are going to have I upon Ig minus 1, this is G upon S, and this will be I minus Ig upon Ig. Here you want to find S. S is going to be Ig into G upon I minus Ig. It's given over here, Ig upon I minus Ig into G. You see, if you want to increase the range of a meter to n times, the shunt needed will be G upon n minus 1. G upon n minus 1. If it is the value of shunt, the range will increase to n times. And you already know, if the range is increased n times, the multiplying factor for the shunt would be equal to n. Now let's switch over to voltmeter. Voltmeter is used for measuring potential difference. It's always connected in parallel, and from that point of view, its resistance should be very high, ideally 0, because in parallel, if the resistance is low, it will consume more amount of current, rather it will draw more amount of current. So in order to get this thing, we always have a very high resistance of voltmeter. How the resistance of voltmeter could be attained high? By adding a simple high resistance in series with galvanometer. Galvanometer along with high resistance in series, this has become voltmeter. Remember, one galvanometer along with a very low resistance in parallel, you might say simply shunt. One galvanometer with a shunt, this has become ammeter. And one galvanometer with high resistance in series, this has become voltmeter. Voltmeter should have high resistance, ideally infinite. If it changes the voltage, and final value is V dash, then fractional change in the voltage will be given by V dash minus V upon V. If you want to increase the range of voltmeter to n times, the high resistance needed in series will be equal to G into n minus 1. It's given over here. As you know, it's always connected in series. The range of the voltmeter is given by this relation Ig, G plus R. Here you know the current that passes through galvanometer is Ig, and the whole resistance of this thing is G plus R.